Hello, and welcome back to Modern Software Management. Today, I want to talk about something that's critically important to anyone managing a software organization, and that's hiring. If you need to hire fantastic coders, fantastic software developers, or you're not going to have a good output no matter what else you do on the management realm. So, arguably, hiring is one of the most important things you can possibly do because you hire a few great, like truly great programmers, and they'll attract other truly great programmers. And those truly great programmers will know how to recognize other truly great programmers, and you'll build more and more, a nice core subset of great programmers. You need a mix of programmers. You don't need all of them to be like truly great, but you need a bunch, and you certainly need a few really great programmers as well. Now, the scary thing when you're hiring is that if you get, from your human resources department, 10 resumes, 10 people that you choose to interview that are actually brought in to interview. Um, at certain periods, I was hiring like one out of those 10 people because, and I was being criticized. Oh, you're being too strict. Bringing you these great guys. They all have university degrees. They have all this and that. Well, I was a university guy. I was a university professor. I was a grad student at the university, and I kind of know the people who are passing some of these computer science courses, and they weren't always the best coders. And people would criticize me. Even some of my own coders would criticize me. Then I brought them into my interview, and when they went through it once with me, they came out the other end and said, "Oh, you're right. You're right, Dave. I would not want that person working beside me. You're absolutely right." How does this happen? Well, let me bring up here on the screen. This is in the day back in '85 or so when I was teaching first year computer science. I was a newly minted grad student, and there was high demand for first year computer science courses, and so they hired me as a lecturer for a first year computer science course, even in the first year of my master's degree. Anyways, in those days, we would typically see in the first year courses this what we call kind of bimodal distribution. In other words, there's a group of people over here who just didn't get it, who just didn't understand programming, and they really struggled. And there was like a distribution around that. And then there were a group of kids in the class who understood programming. They got it. And they were clustered around this mode of the binomial distribution, of this bimodal binomial. It was earlier days, we called it the Sophia-Loren distribution for politically incorrect reasons, as you can see. So you've either got it or you haven't. And later on, years and years and years later, when I came back to be a professor, about almost 15 to 20 years on, I wasn't anymore teaching first year courses, so I didn't have that direct view. I was only teaching upper year courses. But my sense was that this had converged more to a single normal distribution, but that all that was happening was that people were hiding better. Group projects were the thing. And if you've recently graduated from school and been involved in group projects, say you have 4 people who get together and do an assignment, one of them is the one you actually want to hire out of any group of 4, and the other 3 you probably wouldn't want to hire. I think it's more possible to hide, so it's more possible to graduate computer science, and you could really actually be in this mode down here. So you have to figure out how to filter out this mode and concentrate up here. As a matter of fact, more than concentrating up there, if you look at kind of the typical normal distribution, the typical distribution of grades in a computer science course, 10Xers tend to live up here. If they're interested in the course. If they have no interest, if they're doing something else, I mean, they don't have to get good marks necessarily. Sometimes they just love a course and they're really enthused by a course. And then their grade on the course will be representative of what they can actually do. Other times, though, if they're not at all interested in the course and they do something else completely, then their grade in the course won't be that good. So let's assume this is more like a distribution of great programming. And what we generally want to do is we want to find the people we want to find the people on this side of the line over here. Now your 10xers live out here, right? They're pretty rarefied, but those are the ones you really need to find. Those are your racehorses. As soon as you identify one of these, you absolutely want to hire them, no questions asked, immediately. You might put up with a lot of in order to get them, but you also want to seek out people kind of from the middle up in here. This is a great area to hire programmers as well. They will help to get things done. They will maybe smooth things over. They'll be hard workers. They'll be happy doing all sorts of different jobs and things like that. So it's really important to have and they're very, very valuable folks to have as well. And they're great to hire. And you want to test both for if you're up here, if you're competent programmer, and you also want a test that will reveal if you've got a 10xer. We call them 10xers. There's this kind of thing in computer science that your most productive person is very, depending on who you talk to, 10 times or sometimes 100 times more productive than the average person. I think 100 is ridiculous, but I call them 10xers anyways. I used to be a 10xer myself back in the day. I mean, when I coded really intensely from, I'd say, about 85 when I first got into grad school up until about 95, 98. So about 10, 12 years, something like that. I did a lot of coding. I wrote a lot of code. I could code very quickly. I knew, what I wanted to code. I knew how to code it. I knew it had, very few bugs in it. I was really good at it for a while. That was when I was in my 20s and my early 30s. And then after that, I went on to more management type stuff. I do know guys who maintain that status, that 10xer coder status, right up until they retire. Arthur, I'm thinking about you, but and a few others as well. But there are people who do that. And what is a 10xer? What does it mean when you're up here? Like I say, this is it's not about marks. It's not about even IQ, although it correlates obviously. But it's a lot about the 10xers are the people who work on the right things. Even if you as the manager don't know it's the right thing to work on, they are working on the right thing. They are building stuff that's going to be forever maintainable, that's going to be modifiable, that's going to be high quality, that's going to be very operatable, for instance, that'll be very easily debuggable, that will survive all sorts of robustness incidents. They'll be building the right thing. They won't ever build something that doesn't make sense for the end customer either. They're 10xers across the board. When they code, they code extremely productively and in an extremely bug-free kind of fashion. Those are your 10xers. Those are the guys you're really after. And those 10xers, you have to provide the right environment, because you take a 10xer and you put them in the wrong environment, and they're going to look very everyday, very normal. If you can really kill the drive, you can kill the motivation. You cannot give them stuff that allows them to shine. To get a 10xer to be really productive, you need to empower them. You need to give them something meaty, chunky to work on, and you have to empower them. You have to say, go and do it. And you have to kind of unleash them. And if you're like planning, those guys are a little bit off your plan. Sometimes I call them my free radicals. They're a little bit off the plan. They're doing what they want to do because they're 10xers, and they will advance your business in a way that far surpasses anybody else's expectations. Generally, they're not paid as much as they should be paid. The market just doesn't bear that. And a lot of companies just don't recognize when they've got 10xers, unfortunately. And so you don't actually have to overpay for a 10xer. You just have to find them. You just have to motivate them. If you've got a 10xer who can interview another prospective 10xer, and if they come in and tell you, hire that person, then just hire that person. Just don't, if a 10xer is telling you, hire this person, that person is probably a 10xer themselves as well. So one should just go ahead and hire them. So how do you do this? Well, how do you find them? Finding is really tough. Generally, word of mouth. I mean, if you know of somebody, or if somebody knows of somebody, that's the best way. Otherwise, you're relying on recruiters of various types, and you get a swarm of resumes, and then you look on paper, however you want to organize it, to try to find the ones who have the right paper qualifications, anyways, generally. But don't ignore people who don't have the right paper qualifications. They seem to have other qualifications, like are an extreme, like I've done a lot in open source, or have some projects on their resume that are really fantastic. Of course, you don't need that university degree necessarily, although it is helpful to have that university degree, to have that background, that solid background in computer science, which means they've studied all of the things that you really do need to study to be a full, well-rounded computer science. That's a really good thing to have. So you're looking for people who are like that on paper, and then you bring them in for interviews. And again, don't expect a huge hit rate. So how do I interview? Well, my process for interviewing is a bit like this. I say, look, I have their resume, but even though I have their resume right in front of me, and you need to read it in advance, I always start with, well, tell me about yourself. Start from the beginning and tell me in your own words. And they go through in their own words. I ask along the way, have you got any hobbies? And the perfect candidate will have very geeky, technical type hobbies that involve computer programming as well. Then I go on to a sequence of technical questions in whatever their area of expertise is. So whatever their particular area is, I kind of bone up on that a little bit in advance, or if I know it very well myself. And I ask them a series of increasingly difficult questions with the intent of eventually stumping them, and even stumping them on something, but like nobody would know that off the top of the head. They'd have to go look it up. And then you observe what happens when they don't know something. Because the people you don't want to hire will start blustering and will start making stuff up that they don't know is true. The best people will have the self-confidence to say, that's interesting. I don't know that. I don't know how, when you're doing multiple inheritance in C++, what happens if you declare two things like that. This is how I'd go about looking it up, but I don't know that off the top of my head. Perfect answer like that. Okay, so at the end of this, I might say, well, thank you very much for the interview. Goodbye. In which case, they're probably not getting hired. But if they get through this far in the interview, I'll say, do you mind very much if I ask you to code something for me? Like right in front of my eyes, just code something right in front of my eyes. Is that okay? Here, I've got a laptop here. We've got a big projector. I just want you to sit down and I want you to code a very trivial thing. I'll give you a very trivial thing. And if you can go and write some code for me, because I want to see how you think as you're coding. I want you to speak aloud as you code and just show me your process. So I will try to get them to do that. And some people can be offended by that. Although I haven't seen it. That's a theoretical thing. Some people are theoretically offended by that. I've been told, well, you're going to offend people. But not the people you want to hire. They kind of like showing off a little bit. They do coding for a living. I'll tell you the place where I learned this. It was a book called Peopleware, called Productive Projects and Teams by Tom DeMarco and Timothy Lister. See, they were a couple of industry guys, and I think, it was about copyright 1987 over here. Anyways, I love the book, but there's one part of it that particularly I like better than the other ones, and it was called Chapter 15, Hiring a Juggler, on page 100. So let's find page 100. Chapter 15, Hiring a Juggler. So it's a conversation between a circus manager and a candidate. So how long have you been juggling? Oh, about 6 years. Can you handle 3 balls, 4 balls, 5 balls? Yes, yes, and yes. Do you work with flaming objects? Sure. Yeah, I work with flaming objects. Knives, axes, open cigar boxes, floppy hats. I can kind of juggle anything. Do you have a line of funny patter that goes with your juggling? Yeah, it's hilarious. Well, that sounds fine. I guess you're hired. Don't you want to see me juggle? Gee, I never thought of that. Great book, Peopleware by Tom DeMarco and Timothy Lister. Okay, so how do jugglers relate to programmers? If you're hiring a coder, you want to watch them code. And I know many companies give prospective employees tests. Sometimes they're done online, somewhere else, and you type them or you send them something and they send something back or whatever. There's various services that purportedly test their programming and things like that. I've really found that there's no substitute for actually watching them program. It does make people a little bit nervous, obviously. And so you're also weeding out people who get overly nervous, which isn't, maybe there's some argument about whether that's a good thing or a bad thing. But again, if you're a real good coder, your kind of the social anxiety tends to fade away if you can concentrate and get into your code. And the process of speaking aloud really demonstrates how what's going on in their brains as they're coding. And this works even with the most trivial of assignments. I don't like giving them like a tricky thing where you need to like get the trick. Oh, I didn't get the trick. Because that's like some kind of a weird IQ test that isn't that relevant to actually programming. Like they might miss the trick or someone else might have heard the trick and then do the trick. So forget about tricky bits of coding. I like to give them super simple bits of coding so that I can really see them code and understand the thought process that's going on while they're coding. What I'm really looking for is people who just, okay, simple. Well, let me understand, what's my environment? Can I just get a simple program running? Okay, and then they go step by step, extremely logically from beginning to end, and they do the things that they consider to be important, and they mention things that they consider to be important as well, and they show off some of their knowledge. And in a minute, I'll go through and I'll pretend to be the candidate taking the test. And I'll show you what would be kind of the perfect answer. Now, I'm not perfect, okay, but I've had a chance to prepare what I think is the perfect answer. And honestly, I've seen people do as well as I'm about to do, but it's extremely rare. Most people will fail utterly, even on the most simple thing that I'm about to show you. They will fail utterly. They won't even get it working. You have to kick them out after a certain amount of time. Other people will, you just can't bear watching them making these stupid mistakes over and over. So you point them in the right direction. If you point them in the right direction 7 times before they finally get it. Other people will write the most ridiculous algorithms. I don't know where it comes from out of their heads to do a very simple thing. It's crazy what you see. And there's some people, though, who just go about it in a very workman-like fashion. And there's others who will like type it all out and then, it doesn't work. And then poke at it. Oh, look, it works. Good. Well, that's not a good result either. You want them to be systematic. And if something does go wrong, you want them to, you bring up a debugger, figure out what the problem is, fix the problem, keep going like that. So that's what you're looking for. You're looking for clear, concise, level-headed programming thinking. And that correlates very highly with finding your 10Xers. It seems incredible, but that's absolutely true. The problem I set in the old days, and when I was hiring for algorithmics, for instance, there were 2 types of people we would hire: either programmers who also did mathematical models, finance models, so they had to understand a bit of math, a lot of math, and then had to code. Or there were people who we called core programmers; they just had to code. And so I developed a little trivial programming exercise that would test both things, really. So here is one of them. And over my career, I've done many different ones, and many of my colleagues have done different ones as well. And you don't want to be predictable and always do the same one, but I'll give you an example, basically. So I'll say, well, hey, this is the formula to compute the standard deviation. It's called the population standard deviation. If you have a sequence of numbers, the little xi's, where I goes from 1 to n, big N, then you take the mean of those numbers. So the mean is the sum of the numbers divided by n. That's the mean. And you look at the squared differences from the mean of each number, and you sum those squares. You divide that by n, and you take the square root, and that's the population standard deviation. And then I say, and hint, if you do some math on this, it's possible to rearrange it so you can do this in a single pass rather than having to read all the numbers, compute the mean, and then read all the numbers again to compute the standard deviation. And then again, depending on what kind of test it is, I'll say, would you like to try? I can tell you the answer. Or would you like to try to work it out mathematically yourself? And the ones who are like really good at math, they'll work it out mathematically themselves. I'll quickly go over it for you, how the math of that situation works. So the standard deviation down here, the standard deviation is the square root of the variance, and so the variance is that stuff inside the square root sign, right? So moving on, so there's the formula for variance. So let's first expand that into that, right? So that's a simple expansion rule. And then let's distribute the sum over the various terms. So we've now done that. And then you can, with a term like this, there are certain terms that within the summation are constant. So 2x bar is actually constant. It doesn't vary as xi varies. It's only things that have xi that vary. So you can factor out those non-constant, those constant things out of the summation like that. And this last one, x bar squared, x bar is also a constant. So you're basically just adding itself n times. So you can basically, with that one, you can pull that out as well, and you're left with the summation of 1, and which is, of course, n, like that. So then you take your 1 over the n, and you distribute that across like that. And then what you do is you notice, hey, that looks familiar. That sum of xi over n, that is actually the mean. So you can replace that by the mean. And now you've got and you've got the n's that will also cancel out, and you got the x bars that will multiply out. So now we've got that, and then you can look at that, and you've got a -2 and a +1, so that turns into a -1. And there's your formula for variance, right? And so go back, therefore, to standard deviation by putting a square root sign around the whole thing. So this is your one-pass algorithm. It means all you have to do is accumulate the sum of the x squareds to get this part, and the sum of the x's to get that part. So at that point, I then go and ask the person, pick the language. What language would you like to write it in? I will ask, and the person may well answer as follows. Sure, standard deviation. That looks easy enough. So any language you say, well, I can do it in, say, Java or C# if you prefer, but why don't I do it in C? Just because C is kind of low level, it's nearest the machine without going to assembly, which is too low. I'm not prepared to write in assembler. But I can write it in C and demonstrate I know something about the OS as well, if that's okay. No. So C would be absolutely fine. I'd enjoy to see you do it in C. Please, if you don't mind, please go ahead. Sure, I'd be happy to. Let's see now. Okay, first let's find Visual Studio. Where is Visual Studio? There we go. All right, now we can, let's see, create a new project. And let's see, what shall we create? A console? Now I'll start with an empty project. Empty project, let's name it standard deviation, I suppose. Why not? There we go, and create. That creates a solution and a project that belongs to that solution. So let me go into the project, and I'll add a source code file to that. Only C++. I'll just call it main.c. I don't know if it makes any difference to the compiler if it's called C or CPP. I don't think so. Okay, so first thing we have to do is we have to include the standard IO packages as part of the standard library that comes with C. So it kind of enables you to read and write to the console, amongst other things. We'll declare a main routine. You could declare it as void main or int main. Int main means that whatever you return from main, the operating system, that's going to be the exit code. The C runtime startup does that. I just want to make sure everything's working in this environment. So let me just do that much and make sure I can actually run a program. Need a new line so that printf will flush it. Although at the end of the program, again, the C runtime startup that calls main. When it returns, it'll call exit, which will flush everything. And there we go. It says SDev right there, which is exactly what I expected it should do. Excellent. All right. All right. So thank you, me, for that performance. Uh, I'm playing a part, obviously, and I'm answering things really well. Of course, I'm going to, at the end of this, want to hire myself. They always say that that's what hiring managers are looking for. Hiring managers are looking to hire themselves. And by the way, that's a bias. It's very important for you to try to avoid. You don't only want to hire people that are yourself. That applies across races and genders and everything, like just even personalities, everything like that. You want to try to avoid that bias. But for the sake of this exercise, I'm doing the best possible job I can do as myself, and I'll go ahead and I'll comment on all the great things that I'm doing. And I hope you'll forgive me. I'm not trying to be arrogant about it. I'm trying to demonstrate what a really perfect example of this would be, and the types of knowledge that you'd like your candidate to express during this sort of exercise. So if we look at what they did here, so you saw a certain familiarity with Visual Studio, obviously. You saw a nice being vocal, speaking, explaining things clearly. Like that's great as well. When he talked about the return value from main and the C runtime startup, calling main, and about exit codes and things like that, started to demonstrate some real understanding of the operating system and the language and the interaction between those two things. And I also liked how he did the absolute smallest possible program, the Hello World program, and made sure that worked. Because, it's an unfamiliar setting. So you want to make sure that everything works just as you expect it to. So far, at this point in the interview, I'm saying, this guy's looking great. Let's go back and see what's next. All right, so let's make sure that we know how to read a floating point number. So we'll declare x to be the next number in the sequence of floating point numbers. And we'll just try to read that using scanf. It's been a while since I did this, but I think a %f will read in a single precision floating point. You give it the address of x and to read that into. That should input a single standard precision floating point number. It'll skip any white space. And yeah, it returns an integer, scanf does, which is the number of things it read. So it should be 1 if it reads something, or if you hit the end of file, or just the end of file rather, it'll return 0, meaning it didn't read anything. So now let's print out both the return code and the floating point number itself. Okay, and again, it's just, you don't want to go too far without compiling stuff. So let's see if that works. And yeah, actually, so, well, I just want to test this multiple times. I want to try various inputs, make sure I fully understand this. So I'll just, while true, do that. All right, so let's try that. Oh, an error, build error. Build error says, scanf S. Okay, so there's a secure version of scanf. I don't think it makes a difference for this particular thing. But I think for if you're reading a string input, a bunch of characters, there's a possibility of a buffer overrun. It wouldn't apply to floating point numbers, but in general, let's make the compiler stop complaining. Okay, so we can try out various things. Let's try out just basically various things. Look at the program at the same time. Let's see, does it read 1? Yep. Return value 1. And again, a 2, return value 1. Here's a good 1.34. 3. See, does it do E note? It does. Believe it or not, that's correct because of rounding errors. Computers represent these things in binary numbers. Oh, and then there's no way to exit the loop. So of course it kept going when it got 0. I should have gone until the return was 0, indicating end of file, but I'll be sure to actually do that. All right. So a few good things there. Um, first of all, I liked the use of scanf. Most professional programmers won't be actually using scanf that much, so figured out how to use scanf the best way possible by just trying it out and testing it a few times. That's great. Showed a clear understanding of pointers and dereferencing variables to get their pointers for as input to scanf. So that was great that he has this familiarity with pointers. Showed a familiarity with secure coding practice as well. When scanf_s, the secure version, pointed out about buffer overruns if there was a character buffer in there, but wouldn't affect the floats, which is fine. Also displayed an understanding of floating point numbers when he pointed out that when he put in I think 1E23 and it came out as all these nines, and that's just the way arithmetic works on computer. Wasn't surprised by that. Understood about round off errors. So far so good. Keep it up. I'll do the scanf inside the while loop itself. So I'll loop until there are no more floats to read anymore. So as long as I'm still getting back a float, so as long as I still get back one float, I'll still keep looping. When I don't get back any floats, I'll never get a 2 out of this because there's only one thing. So it's either 0 or 1 I'm getting back. Good, and let's just see if that works. So let's just print out the floating point number I receive and just make sure that our input loop works correctly. It's like, I forgot, of course, I forgot to return, so I'll exit success at the bottom, which is 0. I don't know where exit success, it's a macro. I'm not sure where exactly it's defined. So let me look that up. I'd rather use it than 0 or 1, although it's a tight thing. I mean, it's such an idiom. There's a CPP reference defined in, where is it defined? StudyLib header, okay. So include StudyLib. I think StudyLib might include stdio as well. So maybe those are redundant, but it's never a harm including something twice. There's always something that says if this is already defined, then don't redefine it at the top of these header functions anyways. So I'll just enter, yep, and it's found it in that definition. And okay, so let's just test this, see how this goes. All right, let's start typing numbers at it. There we go. Yep. 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 There we go. You can see you can see how many zeros. That's kind of the precision of single point floats. It's like about 7 or 8 digits. And as soon as there was anything that was not a floating point, so I typed A that time, it'll stop. It'll stop looping because it got read back 0 floats. It wasn't able to read something. I think in Windows that's how you do an end of file, or D. I don't know. Anyways, all right. Let's assume that works. It is all right. So now let's. Okay, so we saw some more good stuff there. We saw, for instance, the use of the exit success and exit failure constants. He knew they were defined somewhere, and then a good use of the internet to just efficiently just look them up, not get stumped on it. Displayed an understanding of how header inclusion files work in C. So both those things really great. Let's see what more is coming. So now let's define a few more things. Let's fix some spelling mistakes. There we go. And but actually, let's fill in the comment on the loop. While there are still floats basically in the sequence, I'm going to keep looping. There we go. Oops, another spelling mistake. There should be spell checkers on comments. That would be a good thing. So let's define n now to be the number of floats that I've read so far. Right. So the count of the number of floats, process, input so far. Okay. And then let's define, I'm going to use double precision floating point for all my arithmetic. That's got a little trick. You increase the precision while you're doing arithmetic, and that way you'll have absolutely precise float. If any floats are input, even ones that if you square them, it would overflow. A double can still hold it, and so if I then truncate it to a single precision floating point on output, that'll be at the the accurate, and I won't overrun or anything. So I'll do everything in double. The sum of the x's and sum of the x squared. Yeah, let's call it x squared like that. Yeah, if it were sum of the double x's, it would be sum 2x. So I'll just say sum x2 will be x squared. This is the sum of the floats squared so far. Yeah, so notice all the so fars, both n, sum x2 are the so fars. I'm a bit of a neat freak. When there's related definitions, I like to line them up. I find it's just easier to read afterwards. Just easier on the eye, if you will, to add it all up, don't you think? I think so. I think you can just see it easier. Okay, so while there are still floats in the sequence, read it into x. That's what the while loop does, and then I'll start accumulating them. So first I'll bump n, because I'm in the process of processing one more. There's a loop invariant that basically I have to write 3 statements to reestablish the loop invariant that n, sum x, and sum x squared are what they should be. And n plus the number remaining is always going to be the initial number until n is the initial number, and then the number remaining is 0, and I'll exit. There is no, I don't want to use power function on x. It's simpler if you ask me to just do x squared. There is no built-in square. Okay, so some more good stuff there. The use of float versus double is good. It displays an understanding again of machine arithmetic and how that works. I really like the careful choice of words in the comments. I like the fact that he's commenting as he goes. I like the careful and deliberate use of words to define things. There's thought that goes into naming the variables appropriately. And finally, if you picked up on it, he mentioned loop invariance. And I'll probably do another talk sometime about loop invariance, about proofs of program correctness. But you could see that he demonstrated an understanding that a key characteristic of loops is their invariant plus their exit condition together establishing the post condition of the loop. So displaying some computer science knowledge that I think helps make a better programmer. Again, great so far. And now let's just see that works. Let's just print out the 3 things, basically. The first thing is an integer, and I'll use the %g because that's a character sequence that'll print floats in the best way you can print it. So rather than all those digits, it'll print out like 1E23 or whatever instead. And give it the 3 things and exit success. Okay, so let's give that a try. I never like to go too far without running something. Make sure that my understanding of what this program is doing is still accurate. So there we go. 1, 2, 3, and 3 digits. Input 6 is their sum, and 14 is the sum of the square. 9 plus 4 plus 1 is 14. So that's correct. Good. We could try a few more, kind of more cornery cases, perhaps. Like no numbers. And I get 0, 0, 0 out the end, which is correct. Those are the initial values. So that's absolutely correct. But I don't really want it to go on to the rest of the computation. If there are no numbers input, it will be kind of an undefined value. So I'll put a guard on the rest of my code that says if n is 0, then I'll return with a failure code. You didn't use this thing correctly if you're giving it no numbers. So I'll return 1 rather than 0, or exit failure rather than exit success. I think that's probably the best way to do it. Now we can do some math. So we'll define, first of all, the mean. The mean is the sum of the x's divided by the number of them. That's the mean. And let's just print that out and see, make sure we're getting the mean correct. All right. A bit of arithmetic. And let's see how that goes. Okay. Yeah. Window in the right place so I can see my code. I wish I would stay. Should be 2, right? Yep, 2. Print it out. Let's make sure it works for something that's not an integer value as well. There we go. I won't be able to check this directly, but we'll see if it looks reasonable. Yeah, that looks pretty reasonable. 18 by over 3 is 6-ish. All right, so now let's compute our variance. And if we refer over here to the formula, that's the sum of the x squared over n minus the mean squared, like that. And I don't like that it reformatted it. That is the correct. That order of operations would have worked. I'm just going to add brackets for people who don't see it right away, who don't understand bed mass right away. Why not? I don't. I want to write code that's easy for other people to read. Now let's just output all three of them. Oh, sorry, both the mean and the variance, and we'll see how that works. There we go. And okay, a few more good things. I liked that cycle of a bit of code, a bit of running, a bit of testing, and then repeat. Code some more, run some more, test some more, repeat. That cycle, so you're never too far away from having something that you know is correct and is running. I liked how he redefined the specification of the program as he went. He discovered the n equals 0 case and put some thought into what to do with the n equals 0 case, decided that was an appropriate thing to return a non-zero exit status back to the operating system. That's a very valid decision on what to do that. I like the focus, explicit focus on readable code as was creating the expression for variance, not relying on the reader of the code necessarily understanding order of arithmetic operations in a computer, those BEDMAS laws, but explicitly putting in brackets and he explicitly said, I want to make it easy for people to read my code, which displays an understanding. You're not writing code just for yourself. You're writing code for the next person who's going to have to maintain your code. So again, top marks there. That again. See how that works. My basic test looks reasonable. Looks completely reasonable, I think. But let's just double check. I'm sure there's a standard deviation variance calculator, whatever, out on the web. There we enter data set. Yeah, there it is. One commas or spaces. I'll say commas 1, 2, and 3. And no, it doesn't look right. Population standard deviation, right? There you go. That looks right. Variance is that. And the standard deviation is 0.81 something as well. So we'll just remember that. See if we can do that. And let's do this, compute the standard deviation, and that's the square root. There is no square root function, I noticed. I think I'm missing an include file. See, when it says in squared, that's called an implicit definition. Usually there's a compiler option that you give it to say, like, don't do implicit and require explicit definitions. But I don't know enough about the environment to how to set it right now. But I would set it if I were doing any serious C coding, absolutely. And there, but you can see I got the right one now. And let's just print out that standard deviation now. There you go. Which is the thing I'm after. Hopefully that works fairly well. Let's just take a few tests and make sure. All right, let's try 1, 2, 3. Yes, that was what I saw, that 0.81. And let's try some other tests at this point. Let's try that, should be like some kind of a 0. Yep, 0, absolutely. Let's try, I don't know, let's try some bigger numbers. That's near the limit of floating point. So when I square these, it should overflow the float, and that shouldn't happen. The whole reason I use double was so that wouldn't happen. So what's going on? Well, when you don't know what's going on, you don't know what's going on, use a debugger. So let's go in and stop it at that point in the program. So I need to input some numbers, 130, and then it stopped. There we go, after the first one. So, yep, sum is Correct. Yep. And the sum squared hasn't been run yet, so I'm about to step over and do that one. So where's the step over button? There's the step over button. Oops, so now I've done it, and it's infinite. Why is it oh, I know. X times X, that expression, because both of those are float, that's a float expression. So I have to cast at least one of them into double to make it a double expression. This is one of the most hated parts about C. Like it doesn't, even though you're assigning to something, in this case, I'm doing a plus equal on something. You think it would have known it was a double expression, but not that sub expression part of it. Trips up a lot of people. This should work. This should. Yes, that's correct. It's not infinity anymore. It is what it should be. Absolutely. And let's try something big that has just we'll scale up my 1, 2, 3s. See how that goes. Yeah, that's that same 8.16, whatever. That's good. Good. So some more good things there. Use of the internet to do a run what the population standard deviation was for that little 1, 2, 3 example to make sure things were working appropriately. The most impressive thing was there was a bug, and it was a kind of a subtle bug because that the use of the floats and the doubles, the way he had intended, wasn't working out as it should. And went in and first reaction, use the debugger, go to where the problem is and do the smallest possible thing to understand what's happening. He realized all the bug was happening on that one line, and then knew what the problem was through a little bit of examination, and then demonstrated an understanding of how languages work. Some fancy languages will know the type of the thing you're assigning to, and we'll make modifications down the chain accordingly. But C isn't one of those languages. So C kind of goes from the bottom up. So if you have a float and you do an operation on a float, the result of that is still a float, no matter where you assign it to or what you do next with it. So you had to coerce one of those floats at least into a double in order to proceed. And so again, missed that the first time through the code, but figured it out quickly with the help of the debugger, which is great. All right. I want to print to the right number of digits of precision. I don't want to, so I just wonder, how do I print out a certain number of digits of precision in printf? Sorry, I don't write. I don't much care about my formats when I'm writing out usually. So there's the G. Use the shortest representation, which is either in the E notation or the F notation. And where is the number, minimum number of characters? No, dot number. Precision. Yes. So I think I need a dot number. Let's go in there and percent dot 7. I think you get 7 decimal digits of precision out of a float. And let's make sure it doesn't print. Let's make sure it prints the right number. Yeah. So there's 7 digits of precision. Excellent. Excellent. So not just 7 after the dot, it's 7 digits of precision. Let's see, make sure it prints out something short. Yeah, it prints out something short when it is short. So that's good. I think that's the program, but let me just line a few things up first. So I say I like to be tidy when there's related statements, like that. And let me add a comment. I notice I like the C++ comment style, the slash slash, way better. And obviously it's been taking it. So I'm just going to say what this program does: input a sequence of single precision floating point numbers on the standard input. And they're going to be white space separated, not comma separated or anything like that. White space separated. That white space includes a space or a new line. And then I terminate the sequence with either the end of file or the first non-number that I encounter. Non-number character. No. E would be a non-number character, and that's fine. How do I say this? As the first, of course, EOF, or the first character, not part. That's not part of a standard float representation. Spell it right. Good. And then I say what I'm going to output the standard, the population. We did that and notice that as we were typing the population standard deviation to 7 digits of precision. There we go. And that looks pretty good. Let's just specify the exit conditions. When the sequence is empty, then it returns an error 1. And otherwise implicit, it returns success, error 0. Okay, so again, love the careful attention to detail on the comment at the top of the routine. The time spent rigorously defining the interface. So, and that's so important because it's one thing how something works on the inside, but it's really important to define the interface of something because that's what other people will use. Ideally, on a good routine, people will just need to look at the interface documentation and they won't need to read anything else. And so providing a nice, giving some careful thought to the interface detail and demonstrating how important that is by not saying, okay, I'm done, it works, I'm done, but saying, no, it's programming is more than just making it work. Programming is also about defining things so that so that other people who are going to use your code or maintain your code can understand what you had in mind. So that was great. But let's do a debugger walkthrough. It's not something I advocate. I always like to do a debugger walkthrough of my code, even if it looks fine, even if I think it's looking good. I'm going to do a debugger walkthrough just to make sure that the program is doing what I think it's doing. This program is probably a little too trivial for that to really be required, but let's just see what's going on. Single step through those, and of course they initialize to what I expect them to initialize to. Correct. All those things, and let's keep going and going. And now it's it's hung up. It has to wait for a new line. Let's give it all the input all at once. There we go. N is 0, and that's fine. And let's single step. There we go, and it's now 1. Correct. And let's see what sum of x is my number, and sum of x squared is my number 1. And let's keep going. It gets the next number, and x is 1. So yeah, I've got 2 numbers input now. And then the third one, yep. Yes, and 14. Yeah, okay, so it's kind of doing exactly, and now it should be non-zero after I return like a non-number character. N is 0, return exit failure, but N is not, it is 3. So I can keep going. And now I compute the mean, which gets the mean correct, and the variance as well. That's correct for the variance, and the standard deviation is correct. And I print it out, exactly what I expected, and everything works exactly as I had. So I would say, if this were a real thing, I would write a bunch of automated tests to make sure, basically the things I tested manually, I'd set up a framework to do automated tests, but I presume you don't want me to do that right now. And I'll just say that that's good for now, and we'll just save this project for you and exit. I hope that was acceptable. And there we are at the end of the exercise. Just a couple of more things to comment on. The debugger walkthrough. That's something I advocate. Even if you think the code is doing what it should, you walk through it and make sure that your understanding of how the code works corresponds to how it actually works. I found a bunch of errors. It's worth a ton of testing to just walk through your code. And as you're going, sometimes you notice, oh no, if this happens, that's going to blow up. And so it's a really good practice to get into the debugger walkthrough. It's like doing a code review yourself of your own code, but in a way where you don't bring the same eyes to it. You bring slightly different eyes, the debugger walkthrough eyes to your own code. And then, of course, he mentioned automated testing. He'd been doing a lot of manual testing up to then. And yeah, I wouldn't expect in a quick interview to set up a automated testing framework. It would probably take too long. And so that probably would be bad judgment if you did that rather than demonstrate all your knowledge. So I was fine that he didn't do that automated testing framework, but that he did mention it, that it's something important to do. So you can have a nice suite of automated test cases for your code. Okay, so just to wrap up, the importance of hiring great coders. If you're a manager who manages software development organizations, the single most important thing you can do is hire great coders. If you don't have the great material to work with, you're not managing anything. So you need great material. You need a mix of those 10xer coders, not too many, because they actually interfere with each other destructively at a certain level. So you need a few of those really good 10xers, and then you need a lot of good above average coders. And you don't want anyone in a coding role who can't code, who's down on that other side of that normal distribution, or God help you on the other hump of a bimodal distribution has somehow stuck through school all those years. And again, that inspiration for me, the Peopleware book by Tom DeMarco and Timothy Lister about hiring a juggler. That's something I read early in grad school, and it stuck with me when I became a manager and when I started hiring people. I said, yeah, let's see you juggle. And so let's watch you code in front of my eyes. And you can see that the trivial example, there is so much scope, even in a trivial example, to demonstrate a deep understanding of computer science and programming skill. You could see that's why I went through that whole exercise and showed you how completely one could answer it and how much knowledge you could demonstrate, because that's what happens. And you might want to prompt. If the person isn't being very talkative, you might want to prompt them a little bit to get them talking a little bit more than they otherwise would, and explicitly say, "Hey, talk some more. Show off your knowledge for me, because that's what this is all about." And do the important things you consider to be important in coding. Make sure to do those and demonstrate those things, or at least talk about them if you don't actively demonstrate them. And that will really separate the wheat from the chaff in terms of hiring coders. You'll never hire someone who's a useless programmer, and you'll put yourself in a position to recognize the 10xers. The 10x, you notice them fast. You notice them in the first 5 minutes. They just go through just so confidently and coolly and step by step to get that done as if it looks completely trivial, which you think it is completely trivial, right? Now that you've seen it, but it's not. And again, your above average programmers will get through it, and they might need a prompt or a hint, or they might go a little bit awry because it's a bit of a nerve-wracking situation. So you have to accommodate that. But the above average programmers will get through it and do a very reasonable job on it. Maybe not demonstrate as much knowledge as that 10xer programmer will. And the below average programmers, they will shine out. I mean, or whatever, dim out, however you want to call it. You will notice those below average programmers. And like I say, if you have another above average programmer in the room with you, or a 10xer in the room with you, they will say, thank goodness you did that test, because I would not want that person working beside me, because they'll be injecting bugs into my code all day long that I'll have to go and fix. So anyways, hiring a juggler, bear that in mind. Hire great people. One of the keys to having great success. So thank you very much for watching. Please like and subscribe and all of that good stuff, and I'll talk to you next time. Thank you.